Hello, I am Rabi Jha, and this is How to Pass Core Skills, Vectors and Matrices edition. But today I have a very exciting addition to the cast. Here in the VC with me, we have Dr. Wiz,
Hello.
who's going to run us through some of this epic vector stuff.
All right. So now I'm aware, like some of you who are maybe watching this video later have not heard whatever the heck vectors are. So I'm just gonna run through the basic idea of vectors. So in all its essence, vectors are a coordinate system. And what does that mean? Well, let's take an example. Say you're plotting a graph. So what do you do when you have a graph? You say, okay, I'm gonna go, like, say 5 units down the x-axis. And I'm gonna go, like, say 3 units up the y-axis. And I'm gonna plot a point at that. That's the intersection of these points. And in all its essence, vectors follow the same idea. Now, how are you gonna connect this point to the origin? You would draw a line from the origin that follows the shortest path. And that is the first property of vectors. Vectors are direction specific. What does that mean? So, between any 2 points, a vector will always follow the shortest path. Other than this, as we can see in the beautiful graph that Dr. Jha made, that the vectors are actually they have a point to be at. So it basically implies that vectors also have a magnitude. So vectors, for like say 2 vectors to be equal, they're gonna have the same direction or magnitude. And I know this introduction was not the best, but it was the most basic introduction, and it is what leads us on to our first question.
So for question 1, you have this amazing parallelogram with a bunch of vectors, and they're going to ask you a couple of questions.
Yeah.
So what is this equal to, CE?
So, as I said, what are the 2 properties of vectors that we just discussed? They are direction and magnitude specific. So first of all, for this question, we're going to see what CE is. CE is a line that's going from the point C to the point E. Now this wording here itself is very, very important because vectors are, again, direction specific. So this basically this line gives us the direction. This arrowed line gives us the direction of this vector. Now to figure out the vector that is equal to this CE vector, we're first going to have to see which vectors have the same magnitude. So which vectors have basically got the same length. So here we have 3 possible candidates for that. We have DE, EB, and EA. And now to find out our answer, we're going to use the second property, which is direction. We're going to see which of these 3 candidates have the same direction as the CE vector. And again, we see that DE, it has a different direction, so it is disqualified. Same with EB, so that leaves us with 1 candidate, that is EA, and surprisingly, it does have the same direction. So again, to just give a small brief recap, we basically see which of the other lines in this diagram have the same direction and the same length.
Yeah, now let's head on to question 2, which brings us on to a little addition.
So now we can actually go into a very detailed explanation of this question. Or we can use a trick, a little trick that we basically figured out. And honestly, if you just use that trick, it's gonna make this a lot more easier on you. So what we're gonna do is we're gonna so in this case we have DC plus CB, right? So now we're gonna see which like line or combination of lines completes this triangle. I know it does sound a bit dumb, but trust me, it does work. So in this case, we see that DE plus EB. So these two combinations of lines actually complete the triangle. And that is surprisingly again our answer. So all you have to do here for the next two questions after this one is basically complete the triangle. Do nothing else, just complete it. And see which lines make up that triangle. And the next two questions are basically the same triangle problem, so we're just going to go through that as well. All right, so for the second case of this triangle thing, we have CB minus AB. Yeah. So now, again, we see that there is a combination of two lines which completes this triangle. And what is it? It's CE plus EA. So yeah, there we go. Again, what did we do? We basically saw which lines completed this triangle of the points that were given. And again, third case now, we have DA minus AE. And now again, we're gonna follow this basically the same thing that we have been doing for the last two questions. We're gonna complete the triangle. And now we have basically worked with triangles which covered the entire side of the parallelogram. But what happens if they are a diagonal? Again, you use the triangle, the basic trick, and you see, and you just try to finish the triangle, and you see that the line which completes it, it's DE. And again, that is the correct answer. So that I hope that made sense. So that is basically how you calculate and give the answer to these kinds of questions. You basically just need to finish the triangle and see which lines given in the options actually complete the triangle. That's about it. All right, so now heading on to the next question. So now we're introduced to this new concept. So now, like until now, we were working with diagrams, and now all of a sudden there's letters. Yeah. So now I will introduce you basically to why we have these I, J, and Ks. Now, what these basically are? These are representation of the x, y, and the z axis. So x-axis is like denoted by I basically. Y-axis is denoted by J, and the z-axis or the z-axis is denoted by K. And now we look at the one of the properties of vectors, which is it has magnitude. So the coefficients, so the numbers beside these ij and k's, are basically the magnitude. So they're basically telling us to go -7 in the x direction, 6 in the y direction, and 7 in the z direction in this case. Now, how are we going to solve this? It is incredibly simple, trust me. Don't panic when you see this. So you basically multiply the coefficients of the like terms, which means, in this case, you will multiply -7 with -1, 6 with 3, and 7 with 6. Yeah, so you basically get this. Okay, so yeah, you multiply the coefficients, and then you kind of add the results of the multiplication up. So here it's 42 plus 18 plus 7, which gives us 67. All right, so the next question. This question can either be a question from matrices or vectors. Like it's question number 6, I believe.
Yes, it is.
So yeah, so this question can either be vectors or matrices. So now this question would possibly be, it is the last question for vectors, and it would possibly be the hardest one to figure out. But again, it is a basic, not basic, but really simple question. Trust me, just don't panic. It's basic arithmetic. So now what you're gonna do is, you're gonna, as Rabi is doing here, he's just writing down the coefficients to make our lives easier. So now for our first operation, a plus b. So you guys remember how we like multiplied them? So we multiplied the like terms, the like coefficients. We're gonna do the exact same thing for addition as well. We're gonna add the like terms. So if you scroll up a bit, uh, yeah, so we can see it's 4 for the coefficients of I. So the coefficients for the x axis basically we have 4 and 7. So what do we get when we add them up? We get minus 3.
Yeah, it's
And
-7. Yeah.
yeah, and again we do the same for the j's. So you do minus 2, minus 6, and you get minus 8. So it's minus 8j, and then again here. Okay, and this is again, sometimes the questions might be written as so for the last bit, the b bit, they can be written out as minus 7i minus 6j, and they would just completely remove the k term because it has no magnitude basically. However, if this happens, you just need to basically just write the plus 0. You just assume it exists. So now to add them, what we're going to do is minus 5 plus 0. This gives us minus 5. And that is our vector. You just basically write them out with the I, j, and k terms. So you add them, and whatever the result is, you make a new vector out of it. So you just making a new vector means you are writing them with I, j, and k. And now for the second question, second bit of this question, we're working with, first of all, actually multiplying the both of the vectors and then adding them. So what's happening here is we're multiplying a by 3. So basically multiply the terms and write them out as we're doing here right now. So 12 and minus 6 and minus 15 if you multiply the coefficients of I, j, and k in the first vector. And for the second bit, it's okay. It's minus 28, it's minus 24, and it's 0 because, the last bit was 0, so 0 multiplied by anything is 0. Sorry for the waffle there. Alright, now we have these, and now again we do the same thing as we did in the last question, and we add them. So when we add them, we get minus 16, and we get minus 6 plus minus 24, we get minus 30, and we do minus 15 plus 0, which gives us minus 15. And when we write it out in the form that's kind of given in the question, we get our vector, which is minus 16i, minus 30j, minus 15k. And now for the third bit, we are again introduced to a new concept. So for these moduluses that are around our vectors, uh, what it basically means is we're taking the magnitude. And in graphs, how do you take out the magnitude? You you basically do x2 minus x1 squared plus y2 minus y1 squared and square root all of that. So here we're going to essentially do the same thing. So for the first bit, it says magnitude of A. So we're going to take all the terms of A, so 4, minus 2, and minus 5. And now we're going to square them, which would give us 16 plus, so 4 and 25. All right, and now we need to add them. So this would be 20, 45, I believe.
Yep.
Yep, so that'd be 45. And if you square root that, so if you square root 45, you can just write it as square root of 45, or you can, again, do the expansion. It doesn't matter. It's better if you write it under root of 45. So, yeah, you basically need to, again, to reiterate the steps. Square all of the terms independently, add them, and then add an under root over it. That's how you get the magnitude. Okay. Now for the second bit, we have A minus B. So for this, we are given two operations. First, we have to do the arithmetic on the A vector and the B vector, and then we have to find the magnitude. So what is the operation that is given to us? It is subtraction. So we're going to subtract the A and the B vectors. So all right, there we go. Now if we again do this operation, we just get an 11, a 4, and a 5 because 0. And now we will again to make this simple. You can go to the next step directly, but to just make this simpler, let's just write it in the vector form for, again, simplicity. Just write it in the vector form. So it'd be 11i plus 4j plus 5k. And now what do we see? We have a single vector to work with. Now again, we're going to go through the steps. We're going to square root all of the coefficients independently. And then again, we're going to add them. So it'd be 121 plus 16 plus 25. And this would give us
162, I think.
okay, 162. And now we put on the fancy hat that it has, which is the square root. And that would be your answer for this question, basically. So this was vectors. It wasn't the best explanation, but it should probably it will help you get through the test, and hopefully it helped a bit. Thank you.
Thank you very much for that, Professor Wiz. Now, there's an alternate case you can get for question 6 here, where it's kind of similar, but it's displayed as a matrix instead. And the difference between a vector and a matrix is that matrices can be bigger. They're kind of just like boxes of numbers. In this case, though, the matrices are quite small. And we're essentially doing the same things that we were to the vectors. So for B plus A here, all we're doing is adding the terms on top and the terms on the bottom together. And we get that that is -1 and -9. And for 4b plus 3a, we're doing pretty much the exact same thing as we were doing with the vectors. First, we're going to multiply both of these by 4 and 3 respectively. So 4b is going to be minus 20 and minus 28. And 3a is going to be 12 and minus 6. And now we're going to add these together. So minus 20 and minus 28 plus 12 and minus 6 gives us minus 8 and minus 34. And that is indeed the right answer. And the idea for the magnitude is the exact same as well. I'm not sure if you would still call it the magnitude, but you do the same things. So what you're doing for A, the magnitude of A, you're going to do the square root of 4 squared plus minus 2 squared, which should give you... You could just plug this into your calculator. It'll give you the answer is 2 root 5. But if you worked this out by, squaring this out, that would be 16 plus 4, which gives you 20. Then you would get the answer as root 20. And both should be fine here. And then for the magnitude of A minus B, we're going to do the same thing again. We're going to do... This was A minus B. And we're going to get that equals 9 and 5. And now we're going to take the square root of 9 squared plus 5 squared, which gives us the root of 106. What an amazing number. And that is the correct answer. So that's all there is for question 6. It's starting to get a little bit harder now. And now we get on to question 7. And this is where we need to start getting into multiplication of matrices. So let's see what we have here. To figure out if A times B exists, we need to do a couple things. So we're going to have a look at the number of rows and columns in both of them. So A is 2 rows and 2 columns. And B is 2 rows and 3 columns. And here's a little trick we can use. If the two numbers in the middle here are the same, then we know that you can multiply these two matrices. And the reasoning for that will become clear once we actually do the method. And we can also figure out that the dimensions of the matrix we're going to get are the other numbers. So it's going to give us a 2 by 3 matrix. So now let's actually get into the multiplication. What you have to do... Let me just rewrite these here. So what you have to do is you're first going to start at the top left corner of A. And you're going to start at the top left corner of B. Now the first element here is going to be the top left corner of A times the top left corner of B plus the second element in the first row of A times the second element on the second row of B. This is kind of hard to explain, but essentially what it is you're taking the rows from A and multiplying it by the columns on B. So minus 3 times minus 8, that would give you 24. So this is 24 plus minus 6. And that is the first term here. And if we want to go to the second term on the first row here, what we have to do is multiply the first row on A with the second column on B. So now we are not multiplying these. We're multiplying this and this. So we've got the minus 21, minus 18, and so on. So we're going to have a lot more annoying arithmetic to work out right here. So essentially what row we're on is dictated by the first matrix, and what column we're on is dictated by the second matrix. And if we just actually add all these numbers together now, we should get the correct answer. So we have an 18. Now let's see if this is the correct answer. Oh great, I don't have the correct answer for this one. Let's just assume that that's the correct answer. If anybody spots a mistake in my arithmetic, please do let me know. But now let's look at something slightly different, which you could get for this same question. They might ask you to calculate, for example, a cubed. Now, how do you know if you can cube a matrix, or square a matrix, or multiply it by itself any number of times? Well, the quickest trick is to figure out if it's square. So this is 2 by 2, that's square, so it's going to work. And the reason for this is the same as above, because you're multiplying a 2 by 2 and a 2 by 2. And since these numbers are going to be the same, that means it works. So this is the same method as before. You're just going to first multiply A by A, and then multiply what you get at the end by A again. Do that first, then multiply by us again. And that should give you the answer for A cubed. We can go through that at the end, maybe, if we have time. Now let's get on to question 8. If you thought that the arithmetic was annoying above for the multiplication, then you're in luck, because you've got more annoying arithmetic coming right your way. Here we've got 2 matrices, and we've got to compute a couple things. So these are actually quite easy things to do. It's just, you can be caught out with your arithmetic. And actually, I've been caught out in a single cell here. See if you can spot which one I've got wrong before I get to it. So for 2a, all we're going to do is multiply each of the values in a by 2. So we can see we've multiplied them all by 2. And for 3b, we're going to do the same thing. We're going to multiply all of the values in b by 3. So 3 times minus 4 is minus 12, 3 times 1 is 3, and so on. Now for a plus b, we're going to add together the values which are in the same place. So if we just have a look here, that means we're going to be adding 8 and 4. We're going to be adding 7 and 1, 4 and minus 8, and so on. And this is actually where I made a mistake. This shouldn't be 7, this should be 8, because that's 7 plus 1. Then a minus 2b actually requires us to do some calculation first. So we got to calculate what 2b is, which is very similar to what we were doing above. We're just going to multiply each of the elements in b by 2. So we're going to have a -8, a 2, a -16, a -6. I didn't make this big enough. Another -16 and another -6. And now we're going to do a minus this. And with lots of negative signs, I'm just going to rewrite this again, just to make sure I don't get it wrong. I feel like one of the biggest dangers here is just making a silly arithmetic mistake, rather than actually guessing the method wrong. Because once you know what to do, it should be alright. So this should give us 16, 5, 20, 3, I'm not sure why this is 19 in my answer there. That doesn't seem right. Have I done 2 times b correctly? No, I've not, have I? That's meant to be -16. See, I missed a single 1 over there. And that could have tripped me up right here. Exactly! That sound effect perfectly captures it. So we have 3 plus 16, which is obviously 19, that's right. And a 0. And that is the answer. Now we're getting on to the inverse of a matrix. And this one, they do actually tell you what you have to do in the question. So they say, if A is a matrix, then it's inversible if AD minus BC is not equal to 0. In which case, the inverse of A would equal this. So the case where the matrix would not be inversible is when AD minus BC equals 0. So that's what you're going to do first for, does this inverse exist? So here we have this matrix, and we can see where A, B, C, and D are meant to be positioned in it. So AD is 3 times -7. And BC is -6 times 5. And we can see that this is -21 plus 30, which isn't 0. Therefore, the inverse does exist. So now we actually have to calculate it, based on what they've given us here. So all we're going to do is, we just calculated what AD minus BC was. It was 9. So the inverse of A is going to be 1 over 9 multiplied by, and now we have to swap around some numbers in here. So D, which was at the bottom right, that's going to go to the top right. So I'm going to put that there. And A is going to go to the bottom right now, so 3 is going to go down here. Now B and C stay in the same place, but the sign changes. So the -6 turns into a 6, and the 5 turns into a -5. And now what we do is, since in this box, there's no way to add the 1 over 9 on the outside, so we're going to multiply the matrix by 1 over 9, which just means multiplying each of the terms by 1 over 9. And you can see that's what I've done here. We get -7 over 9, 2 over 3, which is 6 over 9, -5 over 9, and 1 over 3, because that's 3 over 9. Solve the given system of equations using either Gaussian or Gauss-Jordan elimination. And this one, it might initially be unclear. Where even are? How do you apply this to matrices, or vectors, or what? And this is actually quite similar to the form we saw way at the start, where you have the coefficient of x multiplied by x, coefficient of y multiplied by y, coefficient of z multiplied by z. Just like the vectors in question 2 it was, I believe. And they've just named them, instead of I, j, and k, they've named them x1, x2, and x3 here. But they also have them equal to something. Anyway, I don't really know the theory behind this, but I can tell you how you solve it. I think using Gaussian elimination. What we're going to do is, we're going to make a special kind of matrix with a dotted line in the middle. So we're going to take the first equation, say. So the coefficient of x1 is 3, coefficient of x2 is 4, and the coefficient of x3 is 3. And this equals minus 6. So we're going to put minus 6 to the right of the dotted line. And we're going to do the same with the coefficients of the next two equations. So this is minus 1, minus 3, and minus 1, which gives us minus 3. And yes, again, I've drawn this too short. Then we have 1, 2, and 4, which gives us minus 12. And what we're actually doing here is we're solving for x1, x2, and x3. Another way to think about these is like 3 simultaneous equations, which you're then going to work on. Because the values of x1, x2, and x3 are going to be the same in all of these, you're able to do stuff like that. Like this, for example. The first thing I'm going to do is try and get these two at the bottom left to equal 0. But how do I do that? So I'm not modifying the first row at all in this first step. I'm going to leave it be. What I am going to do is use this first row to modify the second row. In my head, I'm going to do 2 times 2. In my head, I'm going to do 3 times the second row. And I'm going to add that to the first row. And that's what I'm going to set as my new second row here. And the reason for that is 3 times minus 1 gives me minus 3. And when I add these together, I get 0. And that's my end goal here for this first step. So that gives me a 0. The next one gives me minus 9 plus 4, so that's minus 5. Then another 0 here. And we have a minus 9, minus 6, which is minus 15. Now, this is interesting. We've already solved that minus 5 of x2 equals minus 15. So we know that x2 actually equals 3. But we're going to keep going anyway with the working. We're going to try and get a 0 down here. And I'm actually going to do something very similar to what I did for the second row. Except this time I'm going to do... What am I going to do? I'm going to do 3 times R3 and take away R1. So we're going to multiply this by 3. That's 3. Take away 3 is 0. We're going to do 6 minus 4, which is 2. We're going to do 12 minus 3, which gives us 9. And minus 36 plus 6 gives us minus 30. And now, actually, just based on the fact that I was lucky over here, we are equipped to solve the entire equation. Because we know what x2 is. And over here we have 2x2 plus 9x3 gives us minus 30. I might just quickly check. Yeah, that was correct. So we can simply solve this by substituting in 3. So And we're going to take away 3 from the other side. Take away 3, take away 6. And that gives us that x cubed equals minus 4. And from there, we can go and plug into any of the equations that we've had before. Let's say maybe the third one from the question, which told us that x1 plus 2x2 plus 4x3 gave us minus 12. And we don't know x1 yet. We do know that x2 is 3. And we do know that x3 is minus 4. So finally, we're just going to work this out. Plus 2 times 3 would give us 6. And 4 times minus 4 would give us minus 16. So 6 minus 16 is minus 10. x1 minus 10 equals minus 12. So x1 equals minus 2. And now all we do is we go back to the original question and write in our values for x1, x2, and x3. This was actually an easy version of the question where we got to stop kind of halfway. What I'll attempt to do, which I'm not sure if I can, is continue the working for what if you didn't have a 0 here? How do you get to that later? So let's say we're in this alternate universe where we're pretending that that's not a 0. We're going to have 3, 0, 0, 4, minus 5, 2, 3, 0, 9, minus 6, minus 15, and minus 30. So the third step we want to do here is get this term to equal 0. And the significance of that is it'll allow us to solve for x3. And from there, we can go backwards up the matrix and do the exact same thing we did already. So we're going to do 2 times this R3, and we're going to take away... We're not going to take away R1. We're not going to do that, in fact. There's a slight problem with that, because sure, we could make this 0. So 2 times 2 is 4, minus 4 is 0. But 2 times 0 is 0. Minus 3 would give us minus 3. And that's where back to square one. We've just moved the 0 around. And that's not quite helping us. What we would realistically want to do is use this line where we've already got a 0 at the start, and use that to create a 0 here. I'm not sure what the best way to guarantee that that's easy to do is. I mean, over here we'd be multiplying this by... What, we could multiply the bottom row by 5, potentially. So 5R3, and we're going to add 2R2 to it, which is starting to become a bit tedious at this point. We're still not modifying that first row. We aren't modifying our second row either here. So 5 times 0 is 0, plus 2 times 0 is 0. Perfect, this is stayed as 0. 5 times 2 is 10, plus 2 times minus 5 is minus 10. So that's a 0, which is great. 5 times 9 is 45, plus 0 is just 45. And minus 30 times 5 is minus 150. And 2 times minus 15 is minus 30. So what we get in the end here seems to be minus 180. The question is, has this worked? 45 x3 should give us minus 180. And if we do minus 180 over 45, we get minus 4, which I believe, if we go back to the question, was the value of x3. From here, once you know one of the values, you can always plug x3 into the second line, still imagining that this isn't a 0 in that alternate universe, and get the answer for x2, and then use them in any of the equations to get the answer for x1. So I believe that wraps it up. I think we've gone over the entirety of vector and matrix core skills. Thanks a lot to Jonathan for this epic fan art. It's great to hear that the last video was able to help people, and I hope this one helped you too. Remember to join the Discord from the link below to keep in the loop.